Hey everyone, and welcome. You might not even realize it, but right now, a massive, almost invisible upgrade is happening to the very foundation of internet security. It's this quiet race against a future threat, one that could literally change everything about our digital lives. So what is this quantum threat, and, more importantly, how are we getting ready for it?
Okay, I want you to just think about this for a second. What if a single key could unlock every secret on the internet? I'm talking every email, every bank transfer, every private message you've ever sent. This isn't some sci-fi movie plot. It's the very real future we're preparing for, all thanks to the dawn of quantum computing.
All right, so first things first, let's break down what this quantum threat actually is. You see, for decades, our entire digital world has been built on these incredibly complex digital locks, encryption. And for today's computers, they're basically unbreakable. But a new kind of key is on the horizon, and it's about to change the game entirely. So here's the bottom line. The math, the cryptography that keeps you safe online right now, well, it's just not built to stand up against the raw power of a future quantum computer. We're talking about a scenario where all those digital vaults we rely on could just be shattered, blown wide open. And that is why teams at Google Chrome, and really all across the industry, are in this race to completely rebuild our web defenses from the ground up.
Okay, so you're probably thinking, well, why not just make the digital locks bigger and stronger, right? It seems like the obvious fix. But as it turns out, that seemingly simple solution has a major flaw. A really, really big one that could actually break the internet as we know it. And the problem comes down to one simple thing: data size. You see, if we try to make our current security certificates quantum safe using the old methods, they just become enormous. We're talking huge. Imagine having to download a massive file every single time you connect to a secure website. The internet would slow to a crawl. It just wouldn't work. And wow, this chart really says it all, doesn't it? On the left, that little bar, that's the size of a security certificate today. It's tiny, totally manageable. But that giant bar on the right, that's the traditional quantum-safe version. It is an absolute bandwidth nightmare. You can see right away that this kind of data bloat is just a non-starter for the fast web we're all used to.
So yeah, clearly just making the lock bigger isn't the answer. It causes way more problems than it solves. So what will work? Well, this is where things get really clever. A super elegant solution called Merkle Tree Certificates, or MTCs for short, comes into the picture.
So what are these things? Well, MTCs totally flip the script on how we do things now. Instead of every website sending this long, clunky chain of digital signatures every time you connect, MTCs use a really smart data structure. It lets a website prove its identity with a tiny, and I mean tiny, lightweight proof that basically just says, hey, I'm part of this huge, pre-verified, secure group of certificates.
And here's a great way to think about it. The old way, on the left, is like having a notary public stamp every single page of a 1,000-page phone book. It's slow, it's repetitive, it's just heavy. The new way with MTCs? It's like the notary just stamps the cover of the phone book once and then gives you a tiny little note that proves your number is inside. See the difference? It's just so much more efficient.
And the benefits of this approach are honestly huge. First off, we completely avoid that massive speed penalty, which means the internet stays fast and seamless for all of us. And this next part is key. It decouples security strength from data size. We can make the encryption stronger and stronger without making the data bigger and bigger. And as a really cool bonus, transparency is baked right in. You literally can't issue a certificate in secret. It has to be part of a public tree, which just makes the whole system so much more trustworthy.
Okay, so this isn't just some cool idea on a whiteboard, right? This is actually happening. Let's take a look at how this new tech is coming to the web, because Google Chrome is already in the process of rolling it out, and they've got a really clear three-phase plan to get it done.
So check this out. The rollout is already happening. We're actually in phase 1 right now. It's a feasibility study with partners like Cloudflare, basically a live test. And every connection has a traditional certificate as a fail-safe, just in case. Then, coming up in early 2027, we hit phase 2. That's when they'll bring in other key partners to help build out the public infrastructure for this whole thing. And then the big one, late 2027. That's phase 3, the launch of a brand new trust framework called the Chrome Quantum Resistant Root Store, or CQRS, that's built from the ground up just for MTCs.
But this whole thing is about so much more than just a security patch. This looming quantum threat, it's actually giving us this incredibly rare opportunity to step back and completely rebuild the foundation of trust on the web. We get to make it better, stronger, and more suited for the modern age. And this new foundation for web security is really being built on three core ideas: simplicity, transparency, and resilience. Simpler, to cut down on complexity and things that can go wrong. Transparent, so that anyone can look under the hood and verify that it's all working as it should. And resilient, so that it's agile enough to handle the next big threat, whatever that turns out to be.
So what does this better foundation actually look like in the real world? Well, for one, a lot more automation to make the whole system way more agile. We're talking about much faster ways to cancel or revoke certificates if they get compromised. And maybe the biggest change of all, we're moving away from these slow, once-a-year audits to a system of continuous, verifiable monitoring. That makes the entire ecosystem so much more accountable and, ultimately, way more secure.
You know, the crazy part is, as this massive change rolls out over the next few years, you and I probably won't notice a thing. The web will just keep working, seamlessly and securely. But it really makes you think, doesn't it? This quiet, incredibly complex, and absolutely critical transition. Could this be the biggest invisible upgrade the internet has ever had?